In this video, we're going to talk about how to describe sets using different methods. Here are the methods that we'll be using. Number 1, inequalities. Number 2, graphs. And then interval notation. And lastly, the set builder notation. So let's start with inequalities. An inequality basically is used to compare two numbers on the number line by their relative size or position relative to one another, right? So for example, here we can say A is less than B, right? Or B is greater than A, all right? So now let's look at how to interpret each of the inequalities, okay? So first one, we have X is less than A. We can also say A exceeds X, so it's just the opposite, right? Or we can also say A is more than X, or A is greater than X, right? Now let's have X is greater than B. Here we can also say X exceeds B, or the opposite, B is less than X, right? Now what if we have X is less than or equal to A? Okay, we can say X is at most A, or X is no more than A. This means that A is the largest or the maximum allowable value for X. So in other words, X can be any real number. We're talking about real numbers in this case. So X can be any real number, and its maximum value is A in this case. Okay, because it says here X is no more than A, or at most A. Okay, now what if we have X is greater than or equal to B? So here we can say X is at least B, or X is no less than B. Okay, so in this case, the smallest or the minimum value X can take is B. Okay, so it can be any real number greater than or equal to B, and its minimum value is, or it's the smallest value it can take is B. All right. Now lastly, we have X is not equal to a certain number, let's say A. Okay, let's look at some examples. So number 1, you have here hurricanes have wind speed of at least 74 miles per hour. So let's denote the wind speed as W. Okay, and it says here at least 74 miles per hour. This means that the minimum wind speed for hurricanes is 74, which means we can have wind speeds greater than or equal to 74 miles per hour, right? Now let's say Mark is planning to buy a laptop with a budget of no more than 80,000 pesos. Let's say the budget is denoted as B, okay? And in this case, his budget has a maximum value of 80,000 pesos. Therefore, he can buy any laptop priced at 80,000 pesos and below. Okay, so we say B is less than or equal to 80,000 pesos. Okay, and then lastly, we have number 3. There were more than 16,000 people in attendance during the 2021 NBA Finals Game 2. So we simply say, for example, if we denote the attendance as A, so we simply say A is greater than 16,000 people, right? Next, let's talk about graphing or describing sets through graphing. Okay, here we will be using the number line. Okay, and then we just plot the values that are included in the set. So for example, if we have a set containing the numbers -4, -1, 0, and 5, then we just plot them one by one. So -4 is this point, this is -1, 0, and 5. Okay. Next, let's say we have the set of all x values greater than -3. Okay, so from the number line here, we start at -3, but in this case, -3 is not included because there's no equal sign, right? So we start at -3, excluding -3. So we draw an open circle, if you will. Okay, and then from -3, since x can be any real number greater than -3, so we include all real numbers to the right of -3, going to positive infinity. Okay, or instead of using an open circle, we can also use parentheses. Okay, so in this case, from -3 again, and then going to the positive direction, going to positive infinity. Okay, next, for example, let's say the set of all x less than or equal to 2. Okay, so here we start at +2, and in this case, 2 is included because of the presence of the equal sign, right? So we draw a closed circle, if you will, right? So from +2, since this includes all real numbers less than 2, including 2, so we include those numbers to the left of +2, going to negative infinity. Okay, or instead of a closed circle, we can use a bracket to indicate that the endpoint is included in the set. Okay, so from +2, we go to the left, or we include those real numbers to the left of +2, so going to negative infinity. Okay, next, let's talk about the interval notation. We will be discussing interval notation together with inequalities and graphs. Okay, so we can better understand interval notation. Okay, so let's establish first some conditions. Let x, a, and b represent real numbers where a is less than b, right? So let's start with, for example, set of all x such that x is a real number and x is less than b. Okay, so let's start with let's start by graphing this set of x values. So here our endpoint is b, so we start at x equals b. However, we do not include b, right? So we draw an open circle. Okay, and then since since x can be any real number less than b, then we include those real numbers to the left of b, going to the negative direction, or going to negative infinity. Okay, and using the interval notation, so the left endpoint in this case is going to negative infinity, right? And then the right endpoint is b. Okay, so these are the endpoints, negative infinity and b. So we enclose them in a parenthesis, okay, open and close parenthesis in this case, because both are not included. Okay, so if an endpoint is not included, we use parenthesis. If an endpoint or endpoints are included, then we use brackets. Okay, so let's say x is less than or equal to b. So from b, including b, so we use or we draw a closed circle. From b, going to the left direction still, or going to the left, or going to the negative direction, to negative infinity. Okay, but in this case, b is now included because of the equal sign. Okay, so still from negative infinity to b, but this time we use a bracket because b is now included. All right, for or in the case of infinity, negative or positive infinity, we always use parentheses. Okay, because infinity is not a real number, right? It's just a representation of an extremely large number. So we cannot include its exact value because we do not know its exact value. Okay, we just know that it's approaching to that direction, to negative infinity or to positive infinity. So we just use parentheses. Okay, so now let's say we have x is greater than a. Okay, so these are real numbers to the right of a. Okay, so from a, excluding a, then to the right of a, going to positive infinity. All right, so the left endpoint in this case is a, and since a is not included, then we use parentheses and then going to positive infinity. Right, that's the interval. And then lastly, next we have x greater than or equal to a. So still starting at a, but in this case, a is now included because of the equal sign, right? So we include a, and then we also include all the real numbers to the right of a. Okay, so from a, including a, going to positive infinity, right? Now if we include all values, in this case all real numbers, then we say the set is from negative infinity to positive infinity. So set of all real numbers from negative infinity to positive infinity. So the interval notation is this one, negative infinity to positive infinity. Okay. Now, what if x can be any real number between a and b, excluding a and b? Okay, so from a going to b, excluding both a and b, right? So we include those x values or those real numbers between a and b, excluding a and b. Okay, so we say from a to b, and we use parentheses because both a and b are not included in the set. Okay, now what if x is, or by the way, this is what we call an open interval. Open because both the endpoints are not included in the set or in the interval. Okay, so let's say we have or x can be any real number between a and b, including this time a and b. Okay, so from a, including a, going to b, including b, and all those numbers in between, all those real numbers to be specific. Okay, so we say interval notation is a to b still, but this time including a and b, both a and b, and this is what we call a closed interval. All right, so now what if one of them is included and the other one is excluded, like this one? X is greater than or equal to a, so we include a. However, x is less than b. Okay, so all numbers or all real numbers in between a and b, including a but excluding b. Okay, so from a, we include a, and then going to b, but excluding b, and then all the numbers or all the real numbers in between. Right, so we use bracket for a, and then we use parenthesis for b. Okay, then next we have, this time we have x greater than a and x less than or equal to b. So this time a is not included, but b is included. Okay, and all the numbers in between them, right? So in this case, we use parenthesis for a, bracket for b, and these last two intervals or last two sets is what we call half open or half closed interval. Okay, because one of the endpoints is not included in the set. Okay, next, what if we have, for instance, x less than a or x greater than b? Okay, so let's consider first the first inequality, this one. Okay, So from A, excluding A, so this is less than A, or all real numbers less than A, right? So we include all those real numbers to the left of A, going to negative infinity, right? And excluding A, right? And then we have here or, so this implies union of the two sets of X values, okay? So from B, it says here greater than B. So from B, going to the right, going to the positive direction, or going to positive infinity, and then excluding B, okay? And to describe this using the interval notation, we say from negative infinity to A, union from B to positive infinity, okay? Excluding both A and B, okay? Now what if X is less than or equal to A? So the same with the previous one, however, in this case, we include both A and B, right? So from A, including A, and then we also include all the real numbers to the left of A going to negative infinity, or the values from B, including B, and all the values to the right of, or all the real numbers to the right of B going to positive infinity, okay? So we say from negative infinity to A, including A, union from B to positive infinity, including B, okay? Next, we have here X is less than or equal to A, or X is greater than B. So A, or I mean from A, including A, going to the left, and then from B, excluding B, going to the right, okay? So in this case, B is not included in the set, and all the numbers in between are also not included, okay? But we include A. Okay, so we say negative infinity to A, then we use bracket for A because A is included, and then we take the union of this interval, of this interval, and B to infinity, excluding B, okay? Then lastly, let's say X is less than A, or X is greater than or equal to B. So again, from A, this time A is not included, and then we go to the left, going to positive, or going to negative infinity, I mean. And then from B, this time B is included, so we go from B to positive infinity, okay? So using interval notation, this is from negative infinity to A. We use parentheses for A because it's not included. Then we take the union of this interval with the next interval. So next interval is from B to infinity, including B. That's why we used here a bracket, all right? Next, let's talk about uh, the last method that we will be using, the SetBuilder notation. In this method, we will just be writing the properties. It's like writing the rule or the condition that the elements of the set should satisfy in order for them to be included in the set. Okay, so we say, for example, if you have a set called set A, we say set A is the set of all X. So again, set A is the set of all X such that, and then we write the properties or the condition or the rule, okay? So for example, let's say we are asked to write the set of all natural numbers less than 10. Remember that natural numbers are counting numbers. So from 1, 2, 3, 4, 5, 6, so on and so forth. In this case, we just we are required to write the set of all natural numbers less than 10. Okay. So using the roster method, again, the roster method, let's just recall the roster method. It's listing all of the members or elements of the set being described. Okay, so for example, in this case, let's say this is called set B, for example. And set B contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, and then we stop at 9 because it says here less than 10. Natural numbers less than 10. Okay? And then using the set builder notation, we say set B. Set B is the set of all X And then this vertical bar here means that, means such that. Okay, so we say B is the set of all x such that x is an element of n, or set n, where n is the set of all natural numbers. Here, this one means element of, or we can just simply say x is a natural number. Okay, and x must be, so we provide the condition, okay, that is required. Okay, so here we say x is greater than or less than 1, okay, because we started at 1, and x must be less than or equal to 9 because we stopped at 9. Or we can also express this as x greater than or equal to 1 and x is less than 10. Okay, so these two intervals mean the same thing. Okay, so let's have another example. Let's say write the set of all real numbers this time, less than -1 or greater than or equal to 2. Okay, so we say set C. For example, let's denote this set as set C. Set C is the set of all x such that x is a real number and x must be less than -1, as said here, or x is greater than or equal to 2. Okay, all right. Okay, let's now work on some examples. Okay, so number 1, we are asked to write the set, in this case set A, which is the set of all real numbers greater than or equal to -3. Okay, let's start with, let's say, a graph. Okay, so in this case, I will be working on these examples by using graph, interval notation, and SetBuilder notation. Okay, so you can pause the video now and you can work on this example on your own, and then we'll check your answer later on. All right, if you're done, then let's check your answer. Let's start with the graph. Okay, so we have the number line, and then we have here -3. This is the only point of interest, if you will. So -3, we start at -3. It says here greater than or equal to. So -3 is included. And then greater than, so we include all those real numbers to the right of -3, going to positive infinity. Okay? And then how about the interval notation? Okay? So again, in this case, the left end point is -3, right? And -3 is included, so we use a bracket. And then this is going to positive infinity. So -3 to positive infinity. And then parenthesis, or close parenthesis in this case. Right? How about SetBuilder notation? So this is set A, right? So we say A is the set of all x such that x is a real number, right, from this condition. And then x must be greater than or equal to -3. Okay. Next, we have set B. Set B in this case is a set of all real numbers except 1. Again, we will be using graph, interval notation, and set builder notation. So you can pause the video now and then work on this example on your own. All right, let's check. Let's first have the graph. So from the number line, here it's said that it's the set of all real numbers except 1. Okay, so we just exclude 1 in this set. Okay, so from 1, excluding 1, so we use an open circle, right? And then we go to the left, so meaning this we are including all real numbers to the left of 1 and to the right of 1. Okay, so this means we can have any real number except 1. Okay, using the interval notation, so we do this portion by portions. For example, on the left hand side, we have this is from negative infinity, right? And then we stop at 1. So from negative infinity going to positive 1, excluding positive 1, so we use parentheses. And then we take the union of this interval with the interval, again, starting from 1, excluding 1, so we are using still a parenthesis, and then going to positive infinity. Okay? And then for the set builder notation, so this is set B. So we say set B is the set of all x such that x is a real number, right? Set of all real numbers. And the condition is that x must not be equal to 1. Okay. Next. Set C is the set of all real numbers greater than negative 2 and less than or equal to 4. Okay, so let's start with the graph. Then we have here the first number, negative 2, or the first point of interest, if you will, negative 2. So we start at negative 2. It says here greater than negative 2. So there's no equal to negative 2. Therefore, we exclude negative 2, right? And then greater than negative 2. So we go from negative 2 to the right. Okay, so let me just put this arrow here for now. Okay, and then next we have 4. So from 4, it says here equal to 4. I mean less than or equal to 4. So including 4, and then less than. So we include x values to the left of positive 4. Okay, and then as you can see, there is an intersection. Okay, so there are x values common to both inequalities. Okay, so we just take the common x values, or the x values in between them. Okay, so these are the x values in between them. Okay, and then again, excluding negative 2 but including 4. Okay, so for the interval notation, we say from negative 2, excluding negative 2, and then up to positive 4. Here we include positive 4. Okay, and then set builder notation, this is set C. So we say set C is the set of all x such that x is a real number, right? So a set of all real numbers. And then the condition we have here, x is greater than negative 2 and less than or equal to 4. Okay. Last number. So we have here set D is the set of all real numbers less than or equal to 0 or greater than 3. Okay. So for the graph, we start with 0. Okay. So from 0, it says here less than or equal to 0. So we include 0 and then less than. So real numbers to the left of 0. Okay, going to negative infinity. Okay. And then we also have here 3. So from 3, it says here greater than 3. So from 3, excluding 3, right, we go to the right. going to positive infinity. Okay, so these are the x values that are included in the set. Okay, and then for the interval notation, so again, we consider this portion by portion. Okay, so for example, this one, on the left hand side, we have from negative infinity up to 0. Okay, and including 0. So we say negative infinity up to 0, including 0. Okay, and then we take the union of this interval with the interval starting from 3, in this case excluding 3, and then going to positive infinity. Okay, and then lastly, the set builder notation. This is set D, so we say D is the set of all x such that x is a real number, right? And then the condition. So we have here x must be less than or equal to 0, or x must be greater than 3.